I think we have to start from here, right? Okay. So today we will discuss about the different coordinate system, right? So before going to discussing the coordinate system, we have to understand why the coordinate system, what is the importance of this coordinate system. So we have discussed basics of sub vectors, right? Then then generally in the vectors or mathematics or EMFT, you can say, we have three types of the coordinate system usually used. First one is the the we have discussed now this rectangular coordinate system. Yes or no? So we have discussed the first one is the rectangular coordinate system. Rectangular coordinate system, and then second one is the circular coordinate system or cylindrical coordinate system, and third one is obviously the spherical coordinate system, right? This is also called circular or the cylindrical. Both are the both you can say, right? So now first we will discuss the we already have discussed the uh, Cartesian in the rectangular coordinate system. So let's say once again we are going to discuss just difference this, and then we will discuss the different elements. Okay. So what are the differential? How we will take the differential? So for that purpose, we have, let's say we have the point in p x y z. Okay, in any of the coordinates. So let's say this is the p point, and p point is nothing but the x, y, comma z. So how it can be measured? So first we have to go in the x direction, then similarly we can go on the xy plane, and then on the projection of this just we take the z. Okay, and that projection is x plus xyz, right? And how it is represented? So we already have seen ax plus ax है ना, plus ay है ना, plus az, right? So that component of these three vectors we can represent like that. Now we are going to discuss the differential elements. Okay, so for the differential elements purpose, I'm just first I'm taking the blank sheet. Let's say we have the, wait for a minute. Sorry. Let's say we have the this one. Okay, so let's say this one is the in the x direction, and let's say this one in the y direction, and let considering this is the z direction, right? So this represents obviously the ax vector, uh, and in this direction this one is obviously the ay vector, and this one is the, let's say, az vector, right? So this is the element, this element we have taken x plus dx, y plus dy, and z plus dz, like that, right? This is the dx, dy, dz depend the elemental increment. Okay, so this length you can say this length from this point to this point or this point to this point, this is the dx. Okay, and this is the change in y. Okay, so let's say we are calling this one as a dy, and obviously this one is the dz. Okay, this is the dz. So we are calling this one as a dz parallel to this. It is this one the parallel to z axis. Okay, so the differential volume differential volume can be calculated by the dV, and it is given by dx, dy, and dz, right? So you can write here a differential volume element. A differential volume element is generated by making the differential changes in which dx, dy, and dz along the unit vectors, along with the unit vectors in the direction of what? Ax vector, ay vector, and az vector. I am repeating once again. A differential volume element, this volume element is generated by making the differential changes in dx in x plus dx, okay, and dy and dz in the direction of ax, ay, z respectively, right? So this is the case for the this one, right? So you can also seen by like this one. Let's say we have one example. Wait for a minute. You can see from this book also, so that you can understand it better. Where is that one? Yes. Yeah, this is visible to all of you? Yes or no?
Yes, sir.
Okay. So you can see here, this one is the pxyz, right? And this is simple point pxyz, and this is the r vector. This is representing the length of this vector, position of this vector. Sorry. So let's say we have changes the in x by dx and by y in dy and z by dz, and we can write this equation uh, by sorry, it is not mentioned here. Okay, no problem, no problem. So I think you have understand, right? This is the dx dy dz. Okay, okay. So now how the length of this? So this is the dx differential length in x direction dy. Okay. So how the dl will be changed? How, what is the dl? Dl is the vector length. dl is the vector length, and this length is given by adding all this uh, dx, dy, and dz in the direction of their unit vector, right? Ax, ay, and az. It will give the dl vector. Okay. And how this dl magnitude of this dl vector is calculated? Simple fundamental, same fundamental, dx square plus dy square plus dz square, right? And how the volume will calculated? So the volume, differential volume, is dx dy dz. Okay. And it represents what? It represents simply the parallel piped. Okay, parallel piped. Okay. So now come to the next picture, that is the surface. Okay. So if you want to calculate the surface, so remember always the volume is the scalar quantity. However, the scalar represent the vector quantity. Sorry, surface represent the scalar quantity, or the length represent the vector quantity. Surface is also the vector quantity. How you can visualize it? So let's say we have to calculate the ds surface. Okay, ds surface in the x direction. In the x direction, we want to calculate this one. Okay, so dy and dz, dy, this surface I am talking about, this surface, right? So just multiplying the this length and this length. Okay, length into brace, simply dy by dz. And what is the direction? The normal direction is the ax. The surface, the direction of the surface is ax. So just we are representing the ds in the direction of x is dy dz into x. Okay, and dsy similar, in similar way, in this direction if you want to calculate, then dx and dz will multiply dx and dz. So this is the dx. Okay, this is the dx and this is the dz. You can multiply and calculate the surface. Okay, so that's why I'm saying this one is, you know, the vector quantity, and this surface is nothing but, simply you can write it. This is the surface. Okay, and the normal when it is multiplied by the normal vector, then it is simply written as a ds vector is equals to ds into an vector, okay, where ds is the differential surface area of the element, like dx dy, dy dz, and dz dx dz, right? So, and when we multiply with their unit vector normal vector, then it will represent the overall surface, okay. It gives the information about that surface, okay. So now how the parallel pipe is calculated, okay. So you can also calculate the volume like this one also, a cross b dot c, it represents simply this one, okay. So a cross b is nothing, a cross b है ना, और इसको आपने a dot b is nothing but the ab cos theta, the angle between the a and b. So same fundamentals is applied here, c cos phi, right? And phi is the angle between the a cross b and c, okay. A cross b, a and b, and the angle between the a cross b and c, right? Now come to the next, that is the circular cylindrical system. And here we can see that there are three parameters are changing, that is the rho, phi, z. So in some book, rho is represented by the r also, right? So you can see here the circular cylindrical coordinate system is a three-dimensional version, and all these three spherical, Cartesian, rectangular, and the spherical are the orthogonal, as you know, right? So in this case, there are three parameters, r or rho, phi, z. So how it is be prepared, how it is be made? So the plane of z, plane of constant z, which is parallel to xy, right? So what we have to do, cylindrical कैसे बनना है? So first we have to go in the radius, okay, and then just move down from that angle for by the phi, and in the z direction if we move, then it will give the what, cylinder, right? So the how it will change, it will change the radius will go from the 0 to infinite, okay, and phi will varying from 0 to pi, and z is varying from minus infinite to, obviously, from infinite, right? Minus z to infinite, minus infinite to infinite, this is the z. And r is varying, or rho is varying from 0 to r, or rho, sorry, infinite, okay. And the phi angle, obviously, 0 to pi. So now just I want to show you the elemental. I already mentioned here, I think. If not, then okay, no problem. Okay, so in for the differential surfaces, let's say we have a part of that cylindrical portion, right? That cylindrical portion, okay. My drawing is not very good, but still you can understand by this one, right? So obviously, what is this? इसको क्या कहेंगे आप? बताइए जरा. Have you any idea? Have you any idea? Please. Is the voice audible or not? Please.
Yes, sir, it is audible.
Okay. So what is this? This is the elemental change in what? Elemental change in what? Elemental change in what? Please. अगर आप यहाँ से सपोज, सॉरी, सिलेंडर का क्या है? सिलेंडर का क्या ले रहे हैं आप? Suppose this is the point. So height means z, okay. So this is the gz, right? And obviously this is the radius, okay. This is the radius. So we are taking the d rho or dr, okay. And this one is, rho d rho is varying, okay. And how the angle is changing, this is the rotation. So we are taking the rho d phi, okay, rho d phi, okay. So the first thing we want to calculate, that is the differential volume, So differential volume is calculated, dV is nothing but the multiplication of all these. So rho d phi dz will represent the volume. Okay, and when we talk about the differential, differential surface area, differential surface area, then this differential surface area is okay. So अब इसको आपको समझना है, how you understand it. Let's say we are taking the this surface, and we are already discussed the surface is the vector quantity. Okay, surface is the vector quantity. So it is the rho d phi. This is the d rho, and let's say we are just taking the surface, this one, okay, and it is the dz. Okay, so or you can say az direction. Okay, az direction. So this, और एक तो ये हो गया, दूसरा सेकेंड यू कैन से इफ यू आर टेकिंग, तो ये वाला सरफेस की बात मैं कर रहा हूं अभी फिलहाल, ऊपर वाले इस सरफेस की, राइट, इस सरफेस की. और अगर मैं दिस सरफेस, इफ यू आर टॉकिंग like this one, this surface, right? Suppose 1, this is a 2, this is a 3. So this represents 1 and this represents 2. Okay. So it is nothing but the rho d phi. However, this is the dz. Okay. And the direction of this, कोई बता सकता है what is the direction? What should be the direction? What's the direction? In the direction of
X. Dx.
यहाँ पर x कहाँ है? यहाँ पर this is rho ना? Rho is varying. Yes. So you can say a rho, right? A rho. And third is the third surface. We can represent like this one. Third surface is like this. Okay. And this third surface is we have the two quantity, that is the dz, okay, and d rho, right. And what is the unit vector? इसका नॉर्मल क्या होगा, कोई बता सकता है? व्हाट इज द नॉर्मल व्हाट इज द नॉर्मल? इसका नॉर्मल इधर जाएगा ना, क्या होगा? ए के सॉरी डी रो तो इधर है ना. रो इज वेरिंग लाइक दिस वन ना. Rho is varying like this one, z is varying like this one. Okay, in the upward direction z is varying. Rho is the radial length. So what is the changing now? Angle. This angle को change कर, that angle is a phi, right? A phi. Is it clear? Yes or no? So there are three surfaces, first, second, third. So you can represent that surface, first one ds rho, and ds rho, how can ds rho be calculated? Please, in the direction of a rho, in the direction of a rho, in the direction of a rho, how it's calculated? Please tell me. Rho into, yes, rho d phi dz in the direction of a rho. This will give the surface area of the s rho, right? In similar way, we can put ds phi. Please tell me what is ds phi? What should be ds phi? ds phi in direction of d phi. Yes, d rho into dz a phi, right? And in similar way, we can write dsz, okay, rho d phi dz, okay. So sorry, az, okay. So by this way, you can calculate the surface, this surface's area, right? And remember, this one is the vector quantity, however, this one is the scalar. Okay. Now come to the next, that is the differential length. Differential length. How the differential length will be calculated? So dl vector is nothing. आप उसको पता है सब कुछ, तीनों का component पता है. Okay, we know about all of these components. So you can write simply d rho a rho vector plus rho d phi a phi vector plus dz az vector, right? By this way, you can calculate the differential length. What is the magnitude? You can calculate the magnitude also, right? By squaring and root. Okay, is it clear? Now come to the next. Okay, so this is the, okay, now we are discussing this one now. cylindrical coordinate system. Okay, so we have seen how these two parameters are varying, and then this. Okay, so how the magnitude will calculated? Magnitude will calculate like this one. Okay, squaring and take the root. Okay, now as you also know that from the dot product rule, okay, a dot b, if in the both the vectors are collinear, or you can say the both the same direction, follow the same direction, then the multiplication, the dot product should be the one. Or if the both the vectors are the orthogonal or the perpendicular, then it means the multiplication, the dot product should be the zero, and same fundamentals are applied here, and you can calculate like this one. If you are talking about the cross product, so rho phi and z, rho phi z. Okay, so just follow the circular rule. Okay, rho cross a phi gives the az, a phi cross az gives the a rho, and az cross a rho gives the a phi. Okay, so based on that cross product fundamentals, you can calculate the this one also, right? Now come to the next, that is the relationship between the cylindrical and rectangular coordinates. Okay, if the coordinate system is given in the rectangular, if you want to change that frame into the cylindrical frame, or if the frame is given the cylindrical and you want to exchange in the rectangular frame, you can also change by this formula, by employing this formula. Okay, so you already, I think, studied in the class 12th or 11th. If you're not studied, no problem. Just to take x is equals to rho cos phi and y is equals to rho sin phi, and based on this, you can calculate the magnitude and the angle. Okay, x rho and angle. Okay, just to apply. Okay, the squaring the both side, and you can take the rho. Rho is nothing but the s square plus y square, है ना? Because sin square theta plus cos square theta equal to 1. And if you divide this one, then tan inverse phi becomes what? Tan inverse phi becomes y upon x, and phi is equals to inverse of tan inverse of y divided by x. You can calculate like that also, right? So this is the frame by which the mathematical explanation how it is converted given in the book. I think there is no need to study that part. Okay, here just we have to apply this formula for the changing into going to one coordinate to another coordinate. Okay, so this is from the cylindrical rectangular to cylindrical. Okay, so arrow fi az is given in the cylindrical frame, and this is in the rectangular frame. So just by applying cos phi sin phi and minus sin phi cos phi, just to have remember this one also, only remember this. ओके एंड दिस, आप ये देखिए दोनों का ट्रांसवर्स है, बस यहाँ पर क्या किया आपने, साइन फाई को माइनस साइन फाई लिया, साइन फाई यहाँ पर, एंड बोथ आर द सेम. ओके, सो इस तरीके से यू कैन चेंज द कोऑर्डिनेट. ओके, the number of problem is given in the book. Okay, now come to the next, that is the spherical coordinate system. A spherical coordinate system, right? So in the spherical coordinate system, we have three parameters once again. Here the radius is there, phi is there, but z is not here, right? तो आपको क्या करना है, first आपने just take the point and take the some point of radius, move around that, and then we have to move also from this side. Okay, so समझ में आ रहा है कि नहीं आ रहा है? Yes or no? Please tell me. Please tell me. Yes or no? So first we
Yes, sir.
changing the radius, then we are changing the 2 pi, and then changing this one. Okay, changing this one. Okay, see my wait for a minute. जस्ट सी मैं क्या कह रहा हूं, आप एक आपने पॉइंट से रेडियस आर लिया, और उसके बाद उसको क्या किया आपने, सर्किल बनाया, सर्किल बनाने के बाद फिर उसको रोटेट किया इन दिस डायरेक्शन. ओके, देन दैट विल रिप्रेजेंट व्हाट, दैट इज द sphere, right? That will represent the sphere, and that sphere is, you know, that sphere is here. My PPT is visible or not?
Yes, sir.
Yes, sir.
On both the link, please, please confirm.
Yes, sir. Visible.
Okay.
Yes, sir.
Okay. So by this way, you can define the spherical coordinate system. Okay. So in the spherical coordinate system, we will this is already known by you, है ना? अब आपको मैं केवल वो बताऊंगा. So that is your important the differential length. Okay. And how the differential length will be calculated here in this you can say spherical coordinate system. So a differential, you can say, in a differential volume element, okay, volume element in a spherical coordinate system, in a spherical coordinate system, coordinate system, wait a minute, coordinate system is obtained by taking the incremental, okay, by taking the increments, okay, in what? कौन कौन से पैरामीटर मिलेंगे बेटा बताओ प्लीज. R, theta and phi. Okay. So change this increments by R को we have changing the R by dr, changing the theta by d theta, and changing the phi by the d phi respectively, right? So how this will come? This will come like this one. I'm taking the 3D picture. I'm trying to make the 3D picture. Okay. So this picture, just see this one, right? Okay. So what is this? तो ये है क्या? अब आपको थोड़ा थोड़ा समझ में आ रहा होगा चीजें. Like this one. Okay. So this is the 1/4 of that part. Okay. So this is obviously this one is the dr. This one is the dr. Okay. And this portion is the r d theta. And you know this one is the जो change देख रहे हैं. This is the component of r sine. How it is formed, I will tell you by the book picture, right? So r sine theta d phi, this one is given. Okay. So now the surface and the volume. First, how the volume is calculated? See, the volume is you can calculate by the formula simply dv, and dv is equals to multiplication of this and this. So obviously this one is r square, and this is simple dr, then simple d theta sine theta d phi, right? So r square dr sine theta d theta d phi, it will represent the volume of this sphere, incremental sphere, right? And now come to that second part. That one is your no, the differential surface area. Okay. Differential surface area, and this differential surface area have three again the part. Let's say we have taken the first part, we have the second phase, and there's a third phase. Okay. So just we're trying to draw that these three phases for the better understanding, for the better clarity. So see, I'm trying to draw. Okay. The first phase, Okay. So what is this? This is nothing but the, please tell me. Okay. बताओ क्या है ये? Please. बोलो. This I have taken this one. This I have taken. Let's say this is the one. So R d theta. This one is the dr. Okay. So what is the direction? Direction obviously a5, right? And when you're talking about this, okay. So this is the simple dr. Okay, simple dr, and this one is the r sine this surface I'm taking. This surface I'm taking. Okay, this one. So this is the dr, and this is the r sine theta d phi. Okay, so what is the direction? Anyone? Anyone can guess?
A theta.
A theta. Very good. A theta. A theta. And in similar way, for the first, you can calculate the AR. Okay, and this is the R sine theta d phi, and this is nothing but the R and d theta. Okay, so how it is calculated? So this one can calculate based on this picture. Okay, you can calculate the surface area. So just to calculate, आप मल्टीप्लाई कर दो और एक एक का फाइंड आउट करते जाओ. आर के डायरेक्शन में फाइंड आउट करना है तो सिंपली आर स्क्वायर साइन थीटा डी फाई, राइट? आर स्क्वायर sin theta d phi, and what the direction? Obviously direction is the AR. Okay, and ds in the direction of ds theta surface area in the surface. If you define the surface in the theta, so how it can be defined from this picture? Okay, r dr, okay, sin theta d phi, a theta vector, and last one is the ds phi, and how it is calculated? R dr d theta a phi vector, a phi vector. Okay, R dr, okay, and a phi vector, R dr d theta a phi vector. Okay, now come to the next, that's the last, that one is your differential length. Differential length. So how the differential length is calculated?
We have next class also.
Hello, sir. We have next class.
Okay, sorry. Wait for a last minute. Just wait for the last minute. That's so that we can wrap up this one. So DL is the length is nothing but the dr AR plus R d theta a theta, okay, plus R sine theta d phi a phi. So we have to calculate like this one, okay, and the magnitude is calculated by the squaring and taking the root. Okay, so okay, thank you.